All right, we're gonna square up a bearing block in a 4-jaw. It's 2.5 by 3, and I usually you start off with a 6-inch scale, and you can use this point here and kind of judge that all 4 corners are kind of even. From here to here, and it's just a guessing game right now. We're at 2.5 this wide. The distance from here to here, this is a little bit less, so we're going to back that off to make it even here to here, here to here, so that will go in. Do it the long way. You can put a big bullnose center in the tailstock and quickly line that up if you want. Now this way, I'll come halfway out, as you can see there. Halfway out, not there. I'm going to go right to the next line. This in here, and what I'll do is kind of even up those lines now so it's just snugged up on your part. That distance there, that's so you get the idea. The one that's a little further away, you snug up. Now I'm going to put a parallel behind here. Tap that in. Put a parallel on the other side, just so that they're in there. And it's parallel. Sometimes you want this bore running square to this face. You can put an indicator on here later on. Now the most important thing is once those parallels in there, get them out, because you don't want to get them in there and turn it on. So now that we're here, I am going to actually back this side off and put a copper shim. It will protect your part. And the idea behind copper is if you use an aluminum shim, it protects the part, but it is soft. We call it dead. There's no compression to it. Copper has a compression, so when you crank down on it, it gives a little bit of an elastic pressure. Aluminum, when you squeeze on it, it squeezes dead. It's kind of like an electrical with aluminum wiring. When you tighten a screw down on a contact, it tightens, it's dead, and with time it arcs out. Copper keeps the compression on that screw and it will not back out. So you're nowhere near, but now this indicator, and it's a 1/2 thou, so it's a pretty fine indicator. I'll take it in close and stay way away from the hole. And now you look at it and see how much of a gap as you roll around. Now we're pretty close, so I can get it closer. And that's close there, and it's backed off on this one. So it's got to move this way to give it more of a gap. So what you do now is you put a little pressure on this side, come to the opposite side, and back it up. Not till it's loose, till it's looser. Don't loosen up. And now a little more pressure on this side. And you keep doing that until it looks, because this is a 1/2 thou, so it's 5, 10, 15, 20, about 30 thou range. So now we can go a little closer again. Get over top of it. So it's not touching it yet, but it's touching it right there. So it means it's touching it. It's got to come down this way. So you just snug up on this and drop it down a bit. touching it there. So what you can do is a little bit more pressure. So now we can push on it a little bit more and get it reading. It's nice when there's a fine adjustment. Okay. And if you want, 1, 2, 3, so now there's no guessing it when you, so it's that there and it's touching here. So it still has to come down this way a lot. There's no movement there, so now we're gonna back off in here and you'll watch it start to come around. And now as that comes closer to that 0, back this off a bit, it's climbing towards that, and I will, so we're within, so now I want the other side. This is high, so I'm gonna push down on that. Loosen off just a bit, because we haven't touched the needle here yet. So as I loosen this off, the idea is the copper is under compression, it's gonna move it this way. As soon as I loosen this off a little bit, you see it moved a bit. This side is the long side. We bring it like that. Now we're all within range, and we want, this is the high side. So this is the highest point. We tighten it a bit. Whoops. And that's still the highest side. So now we're gonna, if it's 10 thou out, we move it 5. If it's 1 thou out, we move it 1/2. There's 1/1000th of an inch. And the idea is to keep pushing on the high side down, but if it does get too tight to move, then like here, you can back this off just, and it moves into place. So now it's bouncing around a lot. Because you've either drilled this hole out or done a rough bore, you're still not gonna get it's gonna bounce around because the bores. So right now this is 5, and that's 1.5. So ideally it's off center line, so that's only 3/4 of the point, 0.00075 off center. 7.5 10/1000ths of an inch. And that's reading 4, and over here it's reading 3.5, so that's only a 1/2 off. And you split that difference because you run off center line. This is running pretty true. That part right there we can bring down a bit. Oh no, we can't. So it's high, we just back this off a bit, and you'll notice that needle will move into place. Don't move it to the 5, move it half the distance. Now the that movement there is just the lines, it's a rough bore. The other thing you can do now, is one more, is you can take that and just see, remember I pulled those parallels out, and you can get an idea how, now at this point, you find out which way, you always just use something. So that way the needle's pushing out. So right there, you can tap it in. This is where you don't want to hit your indicator. You can tap it in, but once you've tap this in so it's running true, you'll have to re-true this up again because it might move. So that's 5, and right there. So see if I can get that to move. Now I've seen many guys smash their indicator trying to tap one in. You have to back it off a bit. You're gonna have to redo your center, but do that. Ideally a little, let's do this a different way. Put this down here, get this cross slide out of the way. Give it some more room to play with. Put this on the back side. So this side's high. Yes. So this side's high. I just have to tap it in a wee bit. And I will, if you can't see it, you will see it when that's moved it a bit. Back to this again. Sometimes you are gonna, if these two are just a stock material, which it looks like, you might be within range, unless this has been surface ground before or machined. See, as I move this side down, the rest is coming out. Now, if you wanted this bore square and you had material on here, you could face that off, then board out, and then you would know that this and this are square to each other. Then you can take this surface, put it down on a surface grinder, and grind that in, and then everything's running square. Right now I'm trying to square something up off of a hot rolled surface, and that's probably as good as I'm gonna get, which is, you know, it's probably 5 thou off, 10 thou off center. So take a pass off that, board out, you're good to go. If you want, if it's just, you can put your boring bar in and take a pass off that, set your zero, so now you know how far to go in, because you zero right off that, true right off that surface. So if you gotta go in, whatever that distance is, 3/4 inch, or I haven't got the drawing with me, then you just go into that number and you would be the exact depth. These coppers, this copper works really well, and when you start doing this yourself, you can feel the back off, you can feel the compression pushing that over, and you can feel it squeezing it down. Copper works great.